The PCL DAF unit is a high-built DAF unit that is used primarily for the separation of fats, oils, and greases, as well as suspended solids in wastewater. Now, the way a DAF operates is the wastewater is pumped from the source, which can be a sump or another source, through our feed pump and into the flocculator. In the flocculator, we mix chemicals. We mix acid, caustic, and coagulant chemicals in the flocculator. The acid and caustic are there for pH control to ensure that we maintain a steady pH between normally 6 and 9 pH. The coagulant is injected in there to help with the flocculation of the solids, fats, oils, and greases. The coagulant changes the charge of the particles so that it binds better to the polymer. Now, the fluid will go through a mixing zone here where we create turbulence in the water so that the coagulant, acid, and caustic can mix with all the wastewater. And then it goes around and around the flocculator to this point where polymer is injected. The polymer is a sticky, viscous substance that attracts the solids, fats, oils, and greases to it and makes the flock larger so that it can grab onto the bubbles that are in the DAF and float to the top. The wastewater is then, it goes through another mixing zone to allow adequate mixing of the wastewater with the polymer to create the flocculant. It then flows into the DAF where it's mixed with what we call white water. And we call it white water because it looks like it's a white milky substance when it goes into the DAF. White water is created by taking some of the effluent of the fluid in the DAF unit, and we pump that out through a recycle pump at high pressure. The recycle pump's head is typically around 205 feet ahead, so we'll get about 85 to 90 psi discharge pressure out of that pump, and it's pumped into the saturation vessel. Now, the saturation vessel is typically where the magic happens. So what happens is we pump the fluid into the saturation vessel, but we're also feeding compressed air into the vessel. The compressed air is usually about 115 psi, and this is mixing, this is supersaturating the water with air, creating microbubbles. As the water flows out into this saturation pipe, and it is then injected into the flocculator at this point and also into the DAF. As this white water is injected into the DAF, it mixes with the wastewater, and the microbubbles that are about 50 microns in size grab on to the flocculated particles and float to the top. At the top, we have a skimmer at the top, and the skimmer will scrape all those solids and sludge over to the sludge hopper on this side, where the sludge will be pumped out with the AOD sludge pump. The clear effluent water floats under a baffle on the other side of the DAF. So it floats under a baffle and up over a weir and into the effluent box, and then is pumped to the destination where effluent water is supposed to go. Now, this DAF has a V-bottom as well because there are always solids that are too heavy to float. So these solids drop to the bottom, and about once every 60 minutes, one of these valves are going to open for about 2 seconds, flushing out all those solids that have settled to the bottom. So the only water that's coming out to your effluent is the clear effluent. We send the bottom solids out of the bottom of the DAF back to the sump, and the sludge is pumped out to the sludge disposal area. When setting up the DAF unit, this is a PCL unit, we send two 50-foot lengths of green PVC hose that are 2-inch in diameter. And we use this so that you can connect a screen and drop this into your sump for the wastewater influent, and then the other end connects to the influent side of the pump. Every hose comes with a 2-inch female cam lock connection. The second hose is used to connect the discharge side of the feed pump, and then it goes in. We connect the other side of the hose to the 2-inch connection on the influent of the DAF. This then flows through our flocculator and into the DAF. The other two connections on the DAF, there is a 4-inch connection, and we send a 4-inch hose that's 50 foot in length for our sand drain, bottom drain valve connections. That will typically be rerouted back to your sump to be recycled through the system. We send a second 4-inch hose to connect to the effluent of the DAF. That will feed to the effluent wastewater. Then on the DAF, we also have another connection. We will send a 4-foot length of 2-inch diameter hose to connect from the sludge hopper to our AOD sludge pump. And then we'll also send a third 50-foot length of 2-inch diameter hose that connects on the discharge side of the AOD sludge pump, and that runs to your sludge tank or where you are wasting your sludge. We supply 200 feet of 3/8-inch poly tubing to connect from the provided air compressor to our pneumatic panel. You will connect one end of that tubing to the compressor, and the other end goes into this push lock fitting. It just pushes into the fitting, and this will feed the air to the DAF and also to the AOD sludge pump. There's a connection here that runs into the pneumatic panel, and then there's also a connection here that ties to the sludge pump. The air that comes into the DAF from the pneumatic panel will flow through these solenoid valves. There's one connection that will feed air to the air saturation tube. There's two more connections in here that will feed air into the pneumatically actuated valves on this side of the DAF. The only air connection that needs to be made, though, is from the air compressor into the pneumatic panel. Other connections that will need to be made once the DAF is on site is there are 3 connections from our air saturation pipe that go from on this side of the pipe that tie from these valves into aeration valves on the flocculator. There's 3 of those connections on this particular skid. Other units will have different numbers of connections. The other connections that need to be made airwise will be also on the air saturation pipe. You'll need to run a tube from all these valves here along the bottom into the valve connections on the DAF unit. We also provide 100 feet of black UV protected polyethylene tube for chemical feed pump connections. This tubing is to connect into the chemical totes and then runs into the bottom of these pump connections for the acid, caustic, and coagulant feed pumps. We also provide a chemical dipstick that you can use to drop into the chemical feed tote. You'll connect one end of your tubing here and the other end to the bottom here. On the discharge side of the pump, to feed the chemical into the pump, you will take that same 1/2-inch chemical tubing, connect it into the discharge side of the acid, caustic, and coagulant pumps, and then run it over the flocculator down into the injection points here that are all listed as coagulant, caustic, and acid. All these connections are compression connections, so you will just have to loosen the nut on the top, feed the tube through, and then tighten the nut on both sides here and on the injection point. We also provide a 3/4-inch PVC braided tubing for the polymer This will connect on the bottom side of the polymer tank and then tie into the suction side of the polymer feed pump, and then it's a hose clamp barb connection. You will connect on the discharge side of this pump and run it over to the polymer injection nozzle quill on the flocculator. Every DAF unit comes with a PLC panel that you will need to bring your power from the plant into this panel. You will just need to customer supplied 480 volt connection will tie into the disconnect box that's on the side of this panel. You just need to bring it in to the bottom. There's a cord grip supplied. You'll bring it into the bottom and tie it in here. Just want to make sure that you have qualified personnel making these connections into the panel. You also need to provide a 480 volt connection to the air compressor. It's 15 amp connection coming from the plant. And then you'll need to supply a single 120 volt connection to the polymer mixer that will sit on the polymer tank. That can just be a 20 amp rated extension cord because the polymer mixer comes with a plug end on it that you just plug into the polymer mixer. The feed pump that is provided comes with a 50-foot SL cord that's already tied into the motor junction box here, and that cord will then just be plugged into the panel in this location. Every pump comes with this 480 volt plug-in connection, and it just plugs into the side of the panel. All the DAF units that are shipped out from our facility here in Georgia have already been tested and commissioned for use on your specific job site for trouble-free operation in the future. The settings in the DAF have been pre-programmed for your specific site, and there is not a need to adjust the settings once the unit is on site. Two items that will need to be provided on site are clean potable water to fill up the DAF unit and also to clean the DAF unit during decommissioning, and a ladder or platform to be able to access the top of the DAF unit. So the first thing you will need to do in order to commission and start up your DAF is you will need to fill the DAF unit with clean potable water. The next step, commissioning and starting up the DAF unit, is you will need to make sure that your air compressor is running and is charged to 115 psi. You'll need to ensure that the air filter regulator is set to the right pressure. Now, it comes from the factory set at 115 psi. If it is set at a different pressure than 115, you'll need to pop this lid up, barely, turn it until you see it at 115 psi on this gauge, and then push it down. You also see the pressure listed on this pressure switch at 115 psi. So the next step in commissioning the DAF unit is to make sure that the recycle pump is rotating the correct direction. This will typically take two people, as you'll have one person at the panel turning the pump on and off really quickly or bumping the pump. The other person will be here checking the rotation to make sure that it is rotating the direction of the arrow that is on the pump. So the next step in commissioning the DAF unit is to turn the recycle pump to hand mode to turn the recycle pump on. This will start the recycle of the unit and start creating the white water. We'll also need to turn on the aeration valve to ensure that the white water is being created to hand mode. So once the recycle pump has been running, you will want to check what the discharge pressure of the pump is from this discharge pressure gauge. Typically, it should be running between 75 and 85 psi. The discharge pressure of the pump is also shown on this pressure switch in the pneumatic panel. You can tell what the influent DAF pressure is on this pressure switch and on this gauge. And this first solenoid is the aeration solenoid valve, but we also look at how much air is feeding into the DAF. And there's a needle valve on this flow meter that you can adjust the air pressure up or down. Now this has been set in our facility, and typically on a DAF of this size, it'll be 2 liters per minute, but we try and run this ball in the middle of the flow meter, and that's a good indication that you're getting enough air into the DAF. After you've started the recycle pump and opened the aeration valve, you'll come up to the top of the DAF to check to make sure that you are getting proper aeration in the DAF unit. This is typically what it will look like. It's a white, milky substance, and so we call it white water. Once it's been confirmed that you're making white water at the top of the DAF, you'll turn off the aeration valve first, and then turn off the recycle pump. Then, at this point, you can turn the recycle pump to auto and the aeration valve to auto, as they've been tested, and we know that they will work. The next thing that we want to test and make sure is operating correctly is the skimmer. So we'll come to this handoff auto switches screen again and turn the skimmer to hand mode and let the skimmer operate. Once that skimmer is turned on, we can check that it's operating from 2 different locations. On the gear drive, you can see the little knob in the middle is rotating. So the skimmers should be rotating so that these skimmer blades and flights are pushing sludge towards the beach. The beach is going to be on the end of the sludge hopper, so this skimmer is rotating in the proper direction. Once the skimmer has been confirmed to be rotating in the proper direction and also that it's running smoothly, not binding or jumping or skipping, you'll turn the skimmer drive off and then move it to auto mode. So the next step is to run the feed pump. The first thing you want to do when running the feed pump is you want to come over to the influent side of the DAF skid and make sure that the isolation valve on the influent feed is open. You'll just turn the valve a quarter turn to make sure it's open, and the valve handle should always be in line with the pipe to indicate that it's open. If it's perpendicular to the pipe, it will be closed. This is very important to make sure that this valve is open before running the feed pump. Once it's been confirmed that the isolation valve on the influent of the DAF is open, you can now run the feed pump. So you come over here and turn the feed pump to hand mode. Turn the feed pump on. And then we can go to the operations screen to check for flow. Right now, the flow rate on this one is set to 50 gallons per minute, and where it is dialing in to come to 50 gallons per minute. If you aren't seeing flow on the feed pump, you'll need to check 2 things on the feed pump. The first thing is you want to come to the feed pump and make sure that the motor is running. And typically you can hear if the motor is running. You also want to check the magnetic flow meter to see if there is flow on here. If it's showing no flow and you've confirmed that the motor is operating, typically you have your influent and effluent hoses on the wrong side of the pump. So all you'll need to do is first turn off the pump, then close the isolation valve, then you'll pull off these cam locks on both sides and you'll flip the hoses to either side. Once that's done, you can open the valve again and go turn on the pump, and you should start to see flow. So once it's been confirmed that the feed pump is operating at the desired flow rate, you'll come back over to the screen, turn the feed pump to off, and then move it to auto mode. The next step is to check to make sure that the sand drain and the bottom drain valves are opening and closing properly. And this will typically take 2 people because you don't want to open these valves for a long period of time. So you'll want to have one person over there looking at the sand and bottom drain valves, and another person turning these valves to hand and then off mode to confirm that they're opening and closing properly. So what you'll do is you'll first go to the sand drain valve and you'll turn it to hand mode, and the person on the other side will confirm if the valve is opening and closing. Then once they've confirmed that it's opening and closing, you'll turn it off, and then you will do the same thing with the sludge drain valve or the bottom drain valve. You'll turn it to hand mode. Person on the other side will confirm it's opening or closing, then you'll turn that valve to off. This is the sand drain valve here. It's pneumatically operated, and there's an arrow on here that indicates if it's open or closed. If the arrow is pointing up, it's in line with the pipe, which indicates that the valve is open. If the arrow is pointing out or towards the tank, it is perpendicular to the pipe and indicates that the valve is closed. This lower valve is the bottom drain or the sludge drain valve. You'll see the same thing with the arrows. Now this valve is open as the arrow is pointing out parallel to the pipeline. If the arrow was pointing up, it would be perpendicular to the pipeline, indicating that the valve is closed. You will see this arrow rotate when the valve is opening and closing. Once it's been confirmed that both these valves are operating properly, you'll turn them both to auto mode. The next thing we're going to check is the operation of the sludge pump. The first thing you will check is to make sure that you have air connected to your sludge pump through this air pressure regulator. It's typically set about 60 psi, which is where we set it in our facility here in Georgia. If it's set higher or lower, you just pop the cap, adjust the pressure back to 60, and push it down. And then you will also make sure this needle valve is open all the way. And we'll adjust the needle valve during startup, because we'll close it to make sure that we don't use too much air from the air compressor running the sludge pump. Now to check to make sure that the sludge pump is operating, we'll turn the sludge pump to hand mode, and you will hear a solenoid valve click, and then you will hear the AOD pump start to pump. Once you've confirmed that the sludge pump is operating, you will turn the sludge pump to off, and then move the sludge pump to auto mode. Currently, the sludge pump is operating very quickly, which would draw a lot of air and take air from the DAF as it's operating. So we'll slowly close this needle valve, which will slow down the operation of the sludge pump. The next thing you will want to check is the operation of the chemical feed pumps. So on the screen, you will hit the More button to get to the chemical feed pump operation. You will check the hand speed of all these pumps, and then successively you'll turn each pump into hand mode, and then go and check to make sure that it matches what the hand speed says. So for instance, the caustic pump is currently set to 8 gallons per hour. We'll turn the caustic pump to hand mode, and then we'll walk over to the caustic pump. And notice on the screen that it's operating at 8 gallons per hour, which is what it was set at in the HMI. After you've checked the operations of each chemical feed pump, you will turn them all to auto mode to prepare the DAF to start up. So once you've confirmed that all the components are in auto mode and are ready to start the DAF unit, you will want to check the DAF on delay and the DAF off delay times. You will go to the DAF settings screen on the left of the HMI, and you will look for the DAF system settings, and the top button says DAF off delay time. Right now it's set for 10 minutes. What this does is it turns off the air when the DAF is shut off, it turns off the air to the DAF unit, but allows the recycle pump to continue running to allow all the air that's in the DAF unit to dissipate naturally, instead of causing geysers coming up out of your DAF if you just shut it off really quickly after it's been running for a while. In most of our HMI panels, you'll have to press and hold this button until the DAF starts up. Once the recycle pump has started, there is a 1 minute delay in the program before the feed pump starts up. And if you look at the screen right here, it's currently showing that the feed pump is off. After about a minute of runtime, which allows the white water to be created on top of the DAF unit, the feed pump will start up, and this button will say running. So once I've started up the DAF, I'll check all the pressures on the gauges to make sure they're operating in the proper range. I'll walk around to make sure the feed pump has started up, and then I like to come up to the top of the DAF to look at the wastewater influent, because I want to make sure that we are starting to build a sludge blanket at the top of the DAF. When you're ready to shut down the DAF, you'll come to the HMI screen, and there's a button in red that says Stop DAF System. You'll press and hold that button, and it will stop the DAF system. Now, the recycle system will continue to run for approximately 10 minutes after you push that button to allow all the entrained air to dissipate from the DAF system. Number 1, DAF won't start. The first thing to check is your e-stop button. You need to pull the e-stop button out. A lot of times that e-stop is set and it hasn't been pulled out. The second thing to look at is to look at the alarm screen. So go to the bottom left button, hit alarm screen. If there's any alarms on there that are alarming, you need to address the alarm. The other thing that I've seen when a DAF system won't start is someone has come along and turned the DAF to off mode. It needs to be in local mode in order for the DAF system to start. Another thing to check if the DAF system won't start is to come to the handoff auto screen and make sure that all your items are in auto mode. If some of them are in hand or off mode, the DAF system may not start. And the final thing to check for when trying to start a DAF system is this green button needs to be press and hold it until the DAF system starts. If you're holding for longer than 5 seconds, there's other items that need to be looked at, but many times people will just press it and expect it to start, and these buttons need to be pressed and held. Another alarm that you may see on the system is a low flow alarm. This means that you are getting low flow through the feed pump, so your magnetic flow meter is seeing flow lower than the set point. Currently, this unit is set at 15 gallons per minute as a low flow set point. If it goes below that, it's going to alarm. Some things to check is to make sure that you have sufficient wastewater to be able to pump. If you go and check your wastewater source, the sump or the tank that you're pulling from, is there enough water in there for the pump to be able to pump? Many times, that is the biggest reason why you'll get a low flow alarm is there's just no wastewater to feed to the DAF. Other things to check is to make sure that the feed pump is in auto mode. If it's in off or hand mode, the feed pump won't turn on and you'll get a low flow alarm. Make sure that the flow meter is also transmitting to the HMI. So you may see flow on the magnetic flow meter, but the HMI is not seeing flow here. And you'll see that in this button right here. So you want to make sure that you're getting a signal from the magnetic flow meter to the HMI. Other alarms that you may see is a pH alarm. This happens when the pH set points, the wastewater is outside of the pH set points that you've set. So if you've set your pH to 6 pH and the water is at 5 pH, you could get a low pH alarm. If you've set your high pH at 9 pH and it's at 10 pH, you'll get a high pH alarm. The first thing to check is to come to the HMI and check the setup utility. Go to the setup utility button, which is on the left side, and you'll click the next button until you get to the pH loop, which is here. It says dosing mode select, and there's a button that says caustic pH control, one that says acid pH control, and one that says dual mode. You want to make sure that it's in dual mode if you're getting a high or a low pH alarm. The next thing to check is to make sure that your caustic and feed pumps are operating on auto mode. So you'll go to the handoff auto switches, hit the next button, and you'll check that the caustic and acid are in auto mode. If they're in off or hand, they won't be feeding enough chemical to adjust the pH. The final thing to check will be the pH transmission on the screen. On the HMI, it's transmitting the pH, but there's also a pH on the pH transmitter on the side of the flocculator. You want to just confirm that those two pH values match. If you're not getting a pH reading here, that could indicate why you're getting a pH alarm. There are times when the feed pump is not going to find the set flow rate very quickly. It might take a lot of time, or the flow rate keeps bouncing around a lot. If that's the case, you'll need to adjust the gain in the flow control loop. In order to get to the flow control loop, you'll go to the DAF settings screen. There's a button down at the bottom called Flow Control Loop Setup. You'll click that button and you'll adjust the gain. Typically we set the gain at 1.0, but if you need it to come to the set flow rate faster, you can adjust the gain down, and that will help the pump or the VFD to find the flow rate faster than it's doing, and it will minimize those spikes in flow rates. The other thing you can do is there's a deadband on here that tells how far away you can be from that set flow rate. So typically we'll set this deadband between 1 and 2 gallons per minute, so that when the pump is flowing, it will be within 1 to 2 gallons a minute of the flow rate of that pump. So if your set flow rate is 50 GPM, it will end up flowing between 48 and 52 GPM because that deadband is 2 gallons per minute. You can also adjust that deadband if you need your flow rates to be tighter or looser to what your set flow rate is. One other alarm that you may see is a low compressed air alarm on delay. Now this alarm is supposed to allow the pressure to dip below a set pressure, which is 90 psi, for approximately 30 seconds before it alarms, because there are times that you'll see the pressure drop below 90 psi for a couple of seconds and then come back up. So if it goes below that set pressure of 90 psi for longer than 30 seconds, you'll hear an alarm and it will shut the DAF system down, because we're now starving the DAF of air. In order to, some of the troubleshooting steps to alleviate this alarm is to first look at the AOD sludge pump. If that pump is running continuously and not stopping, then it will be sucking all the air out and causing the air compressor to run dry. So the first thing you'll want to do if that is happening is there's 2 sludge probes in the sludge hopper. You'll need to go up and clean those sludge probes, because the pump may not be getting the signal to turn off. The second thing to check is the pump itself. If you have a clog in the pump, it will cause that pump to continuously run without evacuating any sludge and continuing to suck all the air from the air compressor. The final thing to check would be the air compressor itself. Is the air compressor tripped, or is it charging back up to its set pressure? So that's the final thing to check on a low air compressed alarm delay. One alarm you may see is a low pump discharge pressure alarm. This happens when the discharge pressure on the recycle pump gets too low, below 80 psi. This means that you're not developing the head enough pressure in the pump in order to be able to supersaturate the air with water. So the one thing to check on a low recycle pump discharge pressure alarm is these valves that are feeding the white water into the tank. Oftentimes people will come and open these valves all the way when they're supposed to be closed part way. We close all these valves part way to build up the discharge pressure on the recycle pump. These also need to be closed part way because it creates a pressure differential which allows the microbubbles to be released from solution. So there are times people may come by well-intentioned and open these valves all the way thinking they need to be open, but they need to be closed at least for halfway, possibly more. And that's the thing to check if you have a low recycle pump discharge pressure alarm. One alarm you may see is a sludge overflow alarm, and that means that the sludge is not being pumped out of the sludge hopper for an extended period of time, and it's imminent that your sludge is going to start overflowing the DAF and spilling all over the floor. The things to check are, first, you want to look at the sludge probes and clean the sludge probes, because you may not be getting that close contact to let the HMI know that the sludge hopper is empty. The second thing, the other reason why you may be getting that alarm is there's a clog in either your discharge hose or in the pump. To check for clogs or to clean out any clogs, first you want to try and pump out as much sludge as you can by turning the sludge pump on and off. And then you will take off the suction and discharge manifolds of the AOD pump, clean out any clogs that may be in there. The final step is to disconnect the hose from the AOD pump to try and clean out any clogs there. And one thing to do is to take some clean potable water at pressure and force it up that tube into the sludge hopper to try and dislodge any clogs that are in that hose or in the sludge hopper.